All right, welcome back, everyone. As mentioned before, we are going to be taking a look at stem plots. It's another way. I always think of this as it's a quick and dirty histogram. It's again used for quantitative data. So right here, I'm going to show you this set of numbers. I don't have any idea. I would not say. I would not say that this really is data because there is no context. Remember, we have to have context for the data in order to understand it. So this is just a set of numbers right now, but I'm going to show you how to do a stem and leaf plot using these numbers. The idea in a stem and leaf plot is we are going to take all of these things and we are going to divide them up into really two parts. Sometimes a stem plot is known as a stem and leaf plot because we're going to have a stem on the left side of this bar and we're going to have leaves on the right. One of the quickest ways that we could do this, data is already rounded, is just think of the leaf has to be one digit. So with this information, it's really easy to do that because I could just imagine the stem is everything on the left side of that line and the leaf is on the right. So looking at this, looks like the smallest stem I have is 11. I'm going to look through the rest of them. I have a 10 over here. I'm going to erase these in a second anyway. 10 looks like my smallest leaf. So I'm not going to do the entire thing, but I've got a 10, 11, 12, 13, 14, 15. I'll probably go all the way up to 21. So here's my ideas we're going through there. I don't see anything. Oh, I do see a 260 there. So we'd actually have a couple of other ones, and I'll throw that in here in just a second. So basically, if you follow through on this, I'm just going to go through each of these things and put the numbers down. It's nice because I don't necessarily have to put them in order, but I have a 192, a 152, a 135, a 110, 128, 180, 260. I'm not going to add that one for right now. It's way out there. 170, 165, 150. Notice I'm now adding another 0 after 150 or the 15. So notice 152, 150. And I'm just going to keep going through all of this. I'll probably fast forward it here, but I'll finish writing all these things in. Alright, so I've gone through and I've written out all of these things from the stem and leaf plot here. And so remember, you can go through and read each one of these numbers. Here's 152, 150, 155, 157, 150 again. Some people really, again, if you use that spreadsheet software, like to take and put these things in order because then it helps you find that middle number. But you can still kind of do it when you're looking at it here. It looks like I have rows 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 20, 30, 40, 53. I have 53 numbers. It's odd, which makes it nice because if I take 53 divided by 2, I'm going to end up with 26.5, which means 26 on the top, 26 on the bottom, and that 0.5, that means there's one right in between them. So I can find the 26 number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So the 26 number is going to be 170. If it was somewhere up in here, I'd have to count a little bit in there, but the center of this graph is going to be 170. Now, I mentioned this is kind of like a quick and dirty histogram. It's really kind of interesting. If I were to take this, let me group all this together here. If I were to take this, you can see the stem and leaf plot. If I turn it on its side, and it looks like I missed one of the numbers there. It looks like that 0 is out of place. It belongs up here. I'll move him. So get back up here. But anyway, that stem and leaf plot on its side becomes a really quick histogram. You notice if I was really good about spacing all these, I could see, but I can tell right away a little bit about the shape of this graph. It looks like it's kind of coming up, and let me do this in a different color, a little bit easier to see, but it looks like it's kind of coming up and then it goes down a little bit, and then it really jumps up and then drops off, and kind of takes off going that way. This histogram, a lot of times it's not a standard shape. It is not symmetric when we're taking a look at it, and it's got this tail that kind of goes off. And one of the reasons this tail goes off is because of this guy way out here. All of the information, the highest one went up to about 220, and then there was this Yahoo out here. We refer to this guy as an outlier. Sometimes when people are working with graphs like this, they will just ignore outliers. You probably have had somebody who understands statistics when they kind of give you when they give you tests and quizzes and grades and things like that, and they say, oh, we're going to drop your lowest. That's kind of only paying attention to the low outlier. A lot of times they should really drop your lowest and your highest, especially if they are way outside normal. If I'm a student that gets 73s and 74s and 75s, and then all of a sudden I have this one test where I got 100, this is a better representation of my work. This 100 is really an outlier, and a lot of times should be ignored, but that would be really mean, and nobody's going to do that to you. At least not in this class. So when you ignore this outlier, this graph still is not symmetric. In fact, it kind of has a strange thing going on here in that it's got two peaks that are going on. And a lot of times that really causes people to start questioning the context. Where did this data come from? Why do I have? Is it, if I were going through and saying these were scores, what is different? Why do I have two sets of them? Are they two different schools? Are they two different classes? Maybe I have a class over here where it's really easy to get scores up in the 180s, and another class that's more difficult and all of the scores are around 120. The center of this graph is 170, so if I go ahead and erase some of this stuff that I did over here, kind of erase the bottom part of that graph there, but the center of this graph is right in here. So it's got peaks on both sides of center. Really makes it difficult to decide as far as like being skewed or not. If I look at this, I tend to see this tail going off this way, that this one ends up being skewed right just a little bit. So again, that is how you can make a stem plot, by simply looking at the data and kind of cutting off everything except for one digit. Sometimes when you're doing that with data, you have to round that data first in order to be able to really work with the stem plot, and you'll be working on that in some of the exercises as well. So our final kind of discussion in this chapter is going to be taking a quick look at time plots, as well as making sure, just kind of summarizing all of the things that we've looked at in the first chapter. So last lesson for chapter 1 coming up next.